they intersect. Whoops, that's not a expected. There we go. So, if you look at these are those two graphs, just on a different program. Here's our intersection points, right? And what do you guys notice about, whoops, not what I meant to do. Notice about those two values? Are they similar to what we got from our do first? Are they more than similar? What are they? They're the same, right? So, this is another way of solving a system of equations. This is called solving by graphing. If you have a calculator, this is the easiest, quickest way. Plot your equations and find where they intersect. And that brings us to today's notes. So, whoops, flipping over to your notes. Again, the solution to a system of equation means you're looking for where your lines intersect. And we have three different types. Independent, which basically means you have two lines that cross at one point. They have only one solution and one intersection point. If something is inconsistent, like here, right, two parallel lines, it means that there is no solution because there's no intersection point. And finally, and I think the most weird, follow along. You have dependent systems which have infinite solutions. Infinite solutions. Basically, all that means is they make up or are the same line. So an example of that is if I gave you two equations, y equals x, y equals 2x over 2, and you try plugging those both into your calculator, you just get a single line because they're the exact same line, just written differently. Questions on solutions or on the different systems? Okay, then let's go very quickly through one model. And the reason that I had you all isolate the y up there is because your calculator's smart, usually, but it's also kind of dumb. Because if you try to plug in something like this into your calculator, it's just going to be like, I don't know what to do with that. So, the first step for these is to simply isolate the y value. Right? You want to isolate y. Get it so it's something you can plug into your calculator. So I label both my graphs, and just so I can keep things organized over here whenever I'm working, I'm going to isolate y in the first equation. So again, I want to get rid of the 2x, so I subtract it from each side. Negative 3y, negative 2 minus 2x. And I want to get rid of the negative 3, so I divide each side by negative 3. Y equals negative 2 minus 2x over negative 3. Now, we are going to start, we can simplify this, right? So negative 2 over negative 3, what does that give me? So negative over negative, y'all? 2/3, right, a positive. So this becomes 2/3, and negative 2x over negative 3 becomes 2x over 3, right? Positive 2x over 3. I've got y isolated, so now I can plug that into my calculator. All right. You take the next 15 seconds to isolate y in the second equation. If you finish that early, go to plot. So not y equals that, right? So we just want an equation. You don't have anything to move on. And let's come back together. Carla, what's our equation? 24 minus 4x. Perfect. Good. So the final two steps are you've isolated y. That means the hard part's done. Graph your equations on your calculator. And third, find the intersection point. Okay. Before release to finish this problem, don't worry about actually graphing it on the notes. Okay, I originally was going to have you guys do that, but that takes too long, one thing, and B, not actually what we're looking at today, working at today. More important about you being able to analyze the graph, as opposed to just copy down points. Okay, so take the next minute then to graph these two equations if you haven't already. Find the intersection point and tell me the answer. So what's the solution? Got 60 seconds. Sorry. I've been mixing it in already. Last period was real bad.
That means no homework?
No, because I still know all of your names. I've just been mixing them up in a moment. And that offer came in late. Good. Move on to the next tab. Still have any questions? Again, if you finish that problem, move on to the next one. Was that negative or negative? Oh, yeah. It's your reminder for saving that. Oh. Next one comes in there. All right. And just to double check your work, if I have not already, here is what your solution should be. One thing that I've seen a couple times today. If on the graph you're just plotting the points, right, but you're not labeling it or anything, so let's say you didn't have this graph, but you had this point here at 5, 4. In a moment, I can understand what you're talking about, but on today's exit tickets or on an exam, if something like that, if you were to just put a point with telling you nothing else about it, that would not count. Yeah, I would not give you credit for that. You need to have your answer either as a point like this or like this. Okay? You need to either tell me the actual coordinates of the point or the values of the x and y. All right, questions? Okay, then you have 7 minutes for practice 1 and 2. You finish early, keep going. But again, 7 minutes for problems 1 and 2. So the difference is slight. Because the x is attached to -3. Yeah, there won't be dependence, non-inconsistent today. So you see this part right here? Know what that means? Yeah. Oh, okay, so you don't have to get y, remember, you don't need to get y, you just divide it away with 3, right, with y by itself. So that'll cancel there, so now it's y equals x minus 9. 1. So,